Normalizing a database. We can start from a form. Here we have a sales receipt, maybe on paper, maybe electronic, and some information we can get out of this form and create a few tables. This is not the entire database. We may use multiple documents to create different views. Each one of those subsets of tables, we call them a view of the database. At the end, we can integrate those views into a complete set of related tables. In this form, we can identify elements from different entities or classes. Each one of those fields belong to a different class. For example, we can identify fields from customer. This could be customer name or ID, phone, email, personal information. Stock keeping unit, description of the item, category, quantity sold, and price. These are describing item information. Of course, we can separate them if one of them does not really belong to a table called item or merchandise. For example, the quantity sold belongs to the sales transaction. The sales transaction itself, a serial number for sale identifies each transaction. The date of transaction, the total, the shipping charge, and subtotal of the items. We do not calculate and store numbers in a database. If we need those subtotals and totals, we can retrieve them through queries and calculate the totals. The first step is to list all those fields we see here and try to group the fields that belong to a specific class. Here I'm grouping the sale ID, date and shipping that belong to the transaction, customer data altogether, and then item data altogether, employee data. We start with first normal form. In first normal form, the repeating group should be separate. In sales transaction, when we have all data items from the sale and customer might buy multiple items at a time. So the stock keeping unit, description of the item, category, quantity, and price, these could be the repeating group. First step, we need to separate this group into a new table and then identify a primary key for them. Stock keeping unit is a good candidate for primary key, as well as the primary key of the transaction. So in first normal form, we separate a table which has a combined key, at least two fields. Here we have separated the repeating group, data about the items, and we have a combined key. Sale ID is included here, and it will be the foreign key that will help to establish the relationship between these two tables. There is a one-to-many relationship between these two tables, because one sale ID might refer to multiple rows, multiple items sold at the same transaction. We check the data one more time to make sure there is no repeating group. One sales transaction is about one customer and one employee is involved, so there is no more repeating group. These tables are in first normal form. Then we look at the second normal form. In second normal form, all fields must depend on the entire key. We'll look at the quantity sold. It depends on both stock keeping unit, the item, and sale ID. You might have different items sold in one transaction. Quantity of each depends on both the item and the sales transaction. The item might be sold different quantities at different transactions, but for a specific transaction and stock keeping unit, we have just one quantity. So it depends on both. On the other side, the price, category, and description, they depend on the item and stock keeping unit, the primary key for item. We don't need to know the sale ID to determine what's the description of the item or the category. Here I'm referring to a business rule in this database design. If we include price or the sale price in table of items, that means the price is fixed. It's not going to change for all transactions. So if the price is going to be different, for example, for the discounts or sales, then the price should not be in the table. It should be part of the transaction. So we need to separate the group of fields that determine the specs of item. Stock keeping unit, description, category, and price. By separating the item table, we don't have partial dependency anymore. Quantity depends on both keys, and we don't have combined keys in the other tables. Now we move to third normal form. In a third normal form, all fields must depend on the key and nothing but the key. Look at the sale table. You can see phone, email, personal information of the customer. It depends on customer ID or name, whatever is the unique identifier of the customer. The customer ID itself depends on sale ID. We can determine that, but we have a group of fields that depend on a field, customer ID, which is not the primary key. It means we need to separate this group with the customer field or customer ID field being the primary key, and then leave a copy of customer ID in this table so that we can establish the connection relationship between the tables. We also have employee ID. Employee ID can depend on sale ID, but any other information about employee, for example, first name, last name, if they're listed, they should be in a different table because they depend on employee ID. So we need to have a copy of employee ID in this table, but then employee ID should be the primary key of a table employee. By separating these two tables, we have this database view in third normal form. And here's the design for the third normal form. All fields depend on the primary key, and we have copies of primary keys of customer and employee in sale table. If there are additional fields in any of these tables, we can get them after integrating the views, or if for sure we know that we need to add those fields, we can add them right away. For example, for the customer table, customer ID is the primary key. We need to know what's the customer first name and last name. For employee ID, as a primary key, we need to add all other personal information plus job title and department of the employee. And we can add them to the table so that we can have a complete record of customer and employee. And one more time, this is a subset of the database. This is a view. This design is a view. We can integrate different views to have a complete schema